In the last video, we took the data set from problem 1 and homework 1, brought it into Excel, and created a more R-friendly format for it. And now we're going to bring that data set into R. So using RStudio, I'm going to go to the import dataset function from text file. I'm over here. And if you remember, this was the data set we created. Homework 1, question 1, it's a comma-separated values file. Double-click that. And we get this preview of what it looks like. Here's the text file itself. It's exactly what we created in Excel. And this is what it's going to look like. I'm going to make things a little bit easier here. I'm just going to call this quest1.dat. I'm going to give it a name that I'm going to refer to in my script. It does have a header, and those are the column names, and everything else looks good. So I'm going to go ahead and import. You'll see quest1.dat appear in my workspace here. It has 60 observations of 2 variables, and this is this Excel-like preview of what that looks like. So great. What the homework was asking you to do, I'm going to go up to File and create a new script so we can play around a little bit. What the homework question was asking you to do was define, first of all, say the mean of each of those samples of 10. Now we could do this using the subsetting function. If you remember last week in lab, in the challenge questions, I introduced this subset function in R, in which you specify subset, and then you have to specify the data set. So we just created data set, quest1.dat. And in this case, if we wanted the mean, if we wanted to just get the sample 1 values, we could do sample equals 1. Now if I were to run this line of code, I'm going to send this to the console, see what pops up here. I have subsetted the data set where only sample equals 1, and what it has done is pulled out the 10 rows from the original data set for sample 1. Once I have that, if I wanted to, I could call this sample 1. I could give it a name. This is sample 1. I'll run that. And then I could simply ask for the mean of sample 1. Now if I ran this, what would happen? I get some crazy error, and it's saying that the argument is not numeric or logical. And the reason is I'm asking R to take a mean of this whole data frame, where really I just want R to take the mean of the numbers in this column. So I would be better to specify mean of sample 1, and within that specify the column measurement. Now within my subset, I'm specifying the column of interest, and I'm asking R to take the mean. If I send that to the console, the mean pops up down here. Now the nice thing about R is that I don't need to create this intermediate variable, sample 1. I could simply ask to take the mean of what I said sample 1 is. I could ask R to take the mean of the subset of sample 1 and grab just the column header. So you can see here I just put the definition of sample 1 into this statement. And if I run this line of code, I get the exact same thing. So you could, sample by sample by sample, use the subset function and grab the means of those 6 samples. That's certainly a fine way to do it. It's functional, but it's not very elegant. Another way to do it is to use the aggregate function. And so that's what I want to talk through right here. And this is following example 1 in your lab handout. What the aggregate function does, it allows you to apply R functions in a systematic way to subsets of data, and provided that those subsets are defined by a level of a factor. This is important, and to get into this, let's use this function str. This is a structure function, and what it's asking R to do is to show you what it thinks the structure of a certain data set is, or a certain data frame is. And I'm particularly interested in how R is interpreting the question 1 data set. So I'm going to type this and send it to the console. And what you see here is that R thinks that there are 60 observations of 2 variables. That's great. Measurement, it interprets as an integer, which it is. These are plant heights or something. These are numbers in integer form. But it's also interpreting sample as an integer. Sample 1, sample 2, sample 3, but that's not strictly correct. These 1s, 2, 3, 4, 5, and 6, these are kind of dummy variables. If these samples came from different farms, this could be, Blue Hill Farm and Stoneway Farm. If these samples came from different people or different areas, these could actually be names, strings of text, whatever it is. There's no numeric meaning really to the 1 through 6. They're just placeholders. So actually sample is what is referred to as a factor. It is a classification variable in this particular data set, and we need R to know that. And the way we tell R that is that we specify the data set, and we specify the column that we're talking about, and then we use this as.factor function. As.factor, same data set, same column. So what this is telling is that R, I want you to treat the sample column as a factor and reassign that classification to the same column. So we're kind of updating the identity of that column. I'll actually put this up here in the script so we can always see what we're doing here. So I'll put it here, and now I'm going to send it to the console. Nothing really happens except that R processed the command. If we want to see what happened, what I could do is just ask for the structure of the data set again. And an easy way to do that, because R keeps all the commands that it's run in memory, is I can just use the up arrow on my keyboard. If I press it once, it shows the last command that I gave to R. If I press it up again, it shows the next one in the history, and that was the structure. So it's a pretty quick way to go back in time. And I run that, and now what you see, R still interprets measurement as an integer, but now it's interpreting sample as a classification variable or a factor with 6 levels. And it really doesn't matter what the names of those 6 levels are, but it recognizes this as a classification variable. Now that we have sample properly identified as a classification variable, we can use the aggregate function. And I'm going to do this up here in the script window so we can keep track of it. The way the aggregate function works, aggregate, or aggregate, let's say aggregate because we're verbing it here. You specify the column in a data set where the numbers are. These are the things that you actually want to perform a function on, find a statistic, find the mean, find the standard deviation, whatever it is. And in this particular case, it's quest1.dat, and our numbers live in the measurement column. Comma, the next argument that goes with the aggregate function is you have to specify the classification variable whose factors are going to be used to apply whatever function you specify to these systematic subsets of data. And in our case, and this is the form of it, you use the list function, and then you specify the column with the classification variable. So what we're saying here is you're going to take a list of all the levels of sample, that's 1, 2, 3, 4, 5, and 6, and for each of those classification levels, I want you to pull the measurement data. And once you've done that, another column, I want you to apply some function to that subset. And in this case, we can apply the mean. If I send this command to the console, lo and behold, what happens is that I get a small data frame where I have the 6 groups listed. These are the 6 factors or levels. These are the 6 levels within my sample factor, and then for each level, I have the mean computed for the 10 samples within that level. And now there's nothing special about the mean function here. I think at this point, I'm going to go ahead and open up the script that I made for example 1. And you have access to this, so it's example1.r. I'm going to pull that up. And what you'll see here is in this script, I've gone through all the commands that I just talked about. We looked at the structure of the data set here. We reassigned sample as a factor. And then we found the requested means by using the aggregate function and applying the mean function. And what I've done in the script is I've taken those means and assigned them to an object that I'm calling means. And I can do other things. I can use this unique function that's going to go down the sample column and find all the unique IDs, and these are going to be my IDs that I can assign to an object named IDs. I can also find the lengths of each of these subsets and assign them to an object I'm calling ends. This is giving me my sample size for each. And if I wanted to compile all of these results into a nice summary data frame for homework in which I would get gold stars, I can create something I'm going to call summary that is going to equal a data frame. This data frame is also a function with an R. I want to create a data frame that is going to combine my IDs, my means, and my ends all together. Let's go through this real quick. So I'm going to send the means to the console. I'm going to send my IDs and the ends to the console. And now I'm going to create a summary data frame. Let's take a look at the summary data frame. What does that look like currently? It looks like this. I have an ID column, I have means X, and I have ends X. Now these headers aren't particularly pretty. So what I can do is in R, I can use this names function with an R, in which I apply names to a data frame, and I'm specifying columns 1 through 3 using square brackets, and I can assign to that a list of labels, sample, mean, and end. I'm going to send line 21 to the console, and now I'm going to look at my summary data frame one more time. And here you can see, by using this names function, I have replaced IDs, means X, and ends X with sample, mean, and end. This is the kind of thing that I could then copy and paste into your homework, and you have a nice, easy way of aggregating all of that data. So take a few minutes, walk through this first script, make sure that you can get the table from the homework into R correctly, and play around with the aggregate function. And we'll come back in the next video, start talking about example 2, the probability density functions.